Welcome to the Image Processing Made Easy webinar. My name is Sandeep and I'm in the product marketing team here at MathWorks. Image processing is a very popular field that we see a lot of our customers use extensively for designing vision-based systems across a variety of different application spaces like automated driving, robotics, machine vision, and medical imaging, just to name a few. Image processing is primarily used in these applications as a pre-processing step, but often it requires more than just image processing techniques to design the complete vision-based solution. So what is image processing? Image processing or digital image processing involves performing certain operations on an image in order to get an enhanced image or to extract some useful information from it before performing further analysis on it. Like in this simple example here, where the main goal is to detect stamps in the video and perhaps count them, image processing has been used for noise removal, edge detection, and filtering operations to pre-process the frames in the video. These processed frames can then be used for detecting the stamps using computer vision and perhaps deep learning techniques. In this video, we will see some vision-based examples where we will focus primarily on the image processing part. We see many engineers and scientists who would like to use image processing in their own projects. However, for someone new to this field, there are numerous challenges with getting started. Some of these typical challenges are, how do I get started? Or how do I learn about different techniques? Or how do I explore options to solve my problem? Or maybe how do I test my ideas on large data sets of images? In this webinar, our goal is to help you get started with applying image processing in your projects through some real-world examples and to show you how getting started with image processing can be made easy and quick using MATLAB. So, in the next 30 minutes or so, we are going to see two vision-related problems in real-world examples and how image processing techniques will be used in each one of them. First, we will see how to improve visibility of objects in underwater images, and second, to identify colored cones or objects in a robot's view. So let's get started with solving some problems. Looking for objects underwater to help with navigation is a common task for submarines. The image on the right is of a small-scale autonomous submarine designed by some engineering students to perform some autonomous navigation tasks. One of the tasks is to locate the submerged gates underwater, like in the image on the right, and autonomously navigate through them. However, there is a problem here that you can see that the gate in this underwater image is not clearly visible. Typically, the visibility of objects underwater are affected due to various reasons, like water movement, debris, or poor lighting conditions. So, the primary objective here is to adjust the image to counter for poor visibility issues before using more advanced techniques to analyze and detect the gate in this image. The solution for this problem is image enhancement. Image enhancement involves applying image processing techniques to adjust image properties, thus preparing the images for further analysis. For example, improving low lighting conditions in images to improve visibility of objects, or increasing sharpness to improve visibility of certain features like edges in an image. Let's now bring up MATLAB and see how to go about solving this problem. So this is my MATLAB environment. I'm going to start off with my MATLAB live script here, where the first thing that I'm going to do is to read in the image of the underwater scene with the submerged gate that we saw earlier. So to do this, I'm going to use the imread function from the image processing toolbox, which takes the name of the image file as input and returns the image data in a variable. Next, I would like to view this image in MATLAB. To do this, I'm using the imshow function, again from the image processing toolbox. So let's run this function and look at the output. So here is my output embedded in the live script, which makes it really easy to follow as we execute this live script section by section. I can also dock out this figure window to take a closer look at it. Now, my goal here is to detect the location of the submerged gate structure in the image. For this, I have a very simple custom function that I've written called find gates. Before we look at this function, let's go ahead and run this next section where I pass the image as input to find gates function. This should return the underwater image annotated with the location of the gate structure. The output result should look something like this. However, as you can see, it fails to find the gates. Now let's look quickly at how the find gates function has been implemented. Without going too much into the details here, the input to this function is an image. First, it is converting the image to a binary. Then it is refining the binary image to remove any negligible pixel regions. And then finally, using region property analysis to detect the remaining large segments, it should give us the vertical structure of the gates. So the output should be two annotations on the vertical structure of the gate. Now, given that the water appears to be murkier than we expected in the image, the find gates algorithm failed to work on this underwater image. This is a common scenario where such failures occur when we design algorithms like find gates even before knowing the actual conditions in the images that we are working with. However, instead of changing the algorithm to work with this image, we could use some simple enhancement techniques available in MATLAB to pre-process the image to see if that would help with the detection of the gate structure using the same find gates function before going ahead and changing the underlying algorithm. Okay, so we know we want to pre-process the image, but what pre-processing or enhancement techniques do we use here for the murky underwater image? Well, what I can do here is to get some help from MATLAB documentation. To do this, I can go to this help search bar and search for enhance image. This should open up MATLAB help browser with the search results for this term. The very first thing here is image processing toolbox, and further down I see a search result on low light image enhancement. I can refine my search results to say I want to only see examples. So here is my refined search. Now in examples, let's look at the one that says low light image enhancement. If you go through this example, you will see a few different techniques that have been used to enhance images with low light conditions. MATLAB gives you the ability to open the script and explore it in an editor window, make modifications and run it to see the outputs without having to implement from scratch. Also here, I can go to the relevant help topic, which is image filtering and enhancement, and learn more about the extensive set of techniques that are available to pre-process your images using the image processing toolbox. Okay, so based on my quick research of these pages and some relevant examples, I was able to pick a few image enhancement algorithms that I would like to try with the underwater image to see if I can make it work with the find gates function. So let's look at this. I have three techniques that I will show here one by one. First, based on the example that we just saw on low light image enhancement, I'm using the dehazing algorithm. For this, I'm using imReduceHaze function from the image processing toolbox, and this should return an output image that has been processed to remove haziness in the image. Typically, dehazing or haze reduction techniques help with adjusting image for atmospheric haze, like images taken from a security camera in foggy conditions, to help improve visibility of objects or overall scene in the image. So let's go ahead and try haze reduction to see if this would help remove some of the murkiness in the underwater image. So let's run this section and see the output next to the original image. As you can see, there are some improvements to certain regions in the image, but is this good enough for our gate detection algorithm? Well, let's go ahead and test this image with the find gates function. So here in the section where I have find gates, I will pick dehazed image from the drop-down menu. Once I pick that, the section is executed automatically, and here is the gate detection result for the dehazed image. So this technique did not really work as we expected. Now I have an option to go back to imReduceHaze function and tweak a few input parameters to see if that gives me a result that would work with the find gates function. I can find out more about these input parameters to imReduceHaze function by looking at the help reference page for the function. But for now, in my case, based on the default syntax here, the resulting image hasn't been successful with the gate detection algorithm. Well, so let's move on to the second enhancement technique here, which is image sharpening. Image sharpening should help with sharpening the edges in the gate structure, which appears a little blurry in the image, mostly caused due to water movement. For this, I'm going to use the IMSharpen function from the image processing toolbox. Let's run the section and look at the sharpened image. It might be hard to notice in this video, but there is some improvement in the sharpness of the edges of the gate structure, but also across the entire image. Now, I want to test the sharpened image with the FindGates function. So let's go ahead to the section again and pick sharpened image from the drop-down menu, and the section executes automatically. As you can see, FindGates has failed again to detect the gate structure. So image sharpening technique hasn't worked either. So far, I've tried two pre-processing techniques and I have been able to quickly test them with my FindGates function, and neither one of them have worked. Next, I'm going to use contrast adjustment to pre-process the image. Adjusting the contrast of the pixels in the image helps with making some lighter pixels stand out in comparison to the darker pixels. And as you can see, since the gate structure has lighter pixels, this technique might help. So let's try it out. Now, to apply contrast adjustment, there are numerous functions available in the image processing toolbox. I've chosen IMAdjust function here. IMAdjust works with both grayscale and color images. Okay, so in this section here, I pass the original image as input, and this should return the contrast adjusted image. Let's run this section and see the output. Well, as you can see, it has thrown an error that the syntax of IMAdjust that we have here is only supported for grayscale images. For a color image, there are additional input arguments that are needed here. So if you look at the help info for IMAdjust, you'll find out that for color images, we need to provide the low and high range for each color channel, R, G, and B. I can type in these numbers as parameters to the function. However, LiveScript provides us with interactive controls that we could use to tune the parameters and see the results update in live. I can tweak these values until I'm happy with the final result.